Okay, so last time, I discussed the stress strain diagram. So ngayon is punta tayo sa tension test na ginagamit natin to get the mechanical properties ng material natin. So, just a recap, ito yung ginawa natin sa stress strain diagram. So we have this stress strain diagram and yung mga different pinpoints stress strain diagram. And we explain this one, mga concept behind this one. And then, after that, discuss din natin itong stress strain behavior ng steel natin and also with regards sa energy absorption na energy absorption ng materials natin. So ngayon, itong tension test. Okay? So, bali may material tayo dito. So, provided yan yung specimen natin. No? Ito yung iti-test natin for tension test. So, ang nangyayari dyan is hihila yung material natin in tension. And then, bali yung number is indicated by the graph area. So, ito yung nangyayari sa vertical na nasa gitna. Ayan. So, nakikita niyo na nag-down yung stress strain diagram. So, meaning, nag-unload yan ng konti na lang. Hanggang naka-unload and then nag-back yan. So, it is rolling down. So, makikita mo na may leaking na nangyayari sa material natin. Kasi ano siya, slowing down. Tapos nag-back. So, ito yung stress strain diagram natin. So, bali yung nangyayari sa material natin is ganito, no? Ayan. So, in the initial section ng diagram natin between the force F and the elongation change in L, and so a direct proportional dependence is observed. No? The sample obey the Hooke's law. Okay. So, at some point in the diagram, Hooke's law is violated. So, the relationship between the force and the elongation becomes non-linear. No? So, makikita mo yan dito. No? Medyo non-linear na siya. Hindi na siya naka-line. No? Non-linear. In the diagram, there is a horizontal area called the yield area. Itong horizontal na to, we call it yield area. Okay? So, at this stage of the test, the sample is elongated or deformed at almost constant force. This phenomenon is called yield. Okay? Yung parang nag-deform siya, we call it yield. So, the sample is deformed evenly along the entire length of its working part. Then, the yield area ends yun dito sa point C. And the hardening area begins. So, dito sa point C, nag-stop na yung yielding. So, mag-start na parang ma-stress out yung material. No? Nag-harden yung strain. So, at the end of this section, the maximum force that the sample can withstand is reached. So, hanggang dito sa point E, so, ito na yung maximum force na na-reach niya. Then, begins the site of destruction. Itong E to F. So, dito yung site of destruction or we call it the site of local fluidity. So, a local thinning or neck appears on the sample. So, such as yung na-observe natin doon sa test. So, nag-nicking siya. No? And the neck diameter decreases as the sample deforms and the sample breaks along the smallest neck section. So, syempre, nag-start na siyang mag-nicking. So, meaning, yung cross-sectional area niya nag-decrease which affect yung stress na kaya niyang i-resist na ngayon. No? Kasi yung stress, alam natin, is very inversely proportional sa area. So if during a tensile test, the load is suspended, for example, at point D, no? Nandito. And the sample is unloaded. So dito bali yung bumaba siya, bumaba yung parang stress strain diagram. So nag-unloaded yan, no? Unloading yung nangyayari. And the previous loading diagram do not coincide. So the discharge line is a straight line parallel to the initial linear portion itong dito sa proportionality limit. So this nature of deformation of the sample during its unloading is called the load unloading. And upon repeated loading, the diagram at point D coincides with the unloading line, and then it will coincide with the tensile diagram of the specimen under single loading. No? Ngayon, pag reload na natin, nakikita natin na nag-coincide siya. No? So this type of deformation is called the law of reloading. No? Like, nag-unload ka and then nireload mo ulit yung load. So, ngayon na-observe mo na nag-continue lang. No? Nag-continue lang yung stress strain diagram niya. And which is maintained up to the value of the force achieved during the initial loading. So, when unloading a sample within the point zero 0.02 A asterisk section, yung dito sa elastic limit, the laws of loading, unloading, and reloading coincide. Okay? So, yun yung ibig sabihin ng stress strain diagram natin. So, ito yung tension test na ginagawa natin sa material natin. Okay, so let's watch it once more. Ayan. Para makita natin ulit yung diagram tsaka yung how the material reacts. Ultimate strength. Okay, so I think that's it. No? So let's continue sa next video. Thank you.